So now let's talk about that what is going to be my performance metric in this case. Now, as if you go back and read it from this page of Facebook, they have given it like they want to look at this mean F1 score. Now we know what is F1 score, right? If you recall that we do have two things like precision and recall. This is your precision, which is like true positive divided by true positive plus false positive. And this is a recall, which is true positive divided by true positive plus false negative. And we used to compute F1 score by using this method. So we know about F1 score, but what we have to figure out is mean F1 score. Now there are two ways to get that. When you're working on multi-label classification problem, one is your micro average F1 score and second is your macro average. Micro average is more famous, and in fact when Facebook have mentioned that they want mean F1 score, they are referring to a micro average F1 score. A thumb of rule I would suggest you is to always go for micro average score. This is far better than macro. I will explain you what are these and what is the difference between them and why I'm telling you that you should always go for micro F1 score. So I will be explaining you all that. Now, in order to understand this, what we are going to do in this case is, let me quickly go back to my same formula of precision and recall. Now, as I told you, if you go back to precision recall, this is a precision, right? Which is true positive divided by true positive plus false positive. So let me go back here and note it down. So if I say precision, so your precision is true positive divided by true positive plus false positive. This is a simple precision metric. If I have to talk about recall, so my recall is going to be true positive divided by true positive plus false negative. Now, if I have to talk from the perspective of micro F1 score, now I have to go with some difference in formula. Let me explain you what is this formula. So now my precision is going to be turn out to be little different. Now the difference is going to come like if I have to calculate, let's say F1 micro. So this is gonna become the same value, because if you recall my basically my this simple F1, if I have to compute, my F1 was nothing but this is going to be 2 of precision into recall divided by precision plus recall. Okay, this is going to be the case here. Now here basically 2 positive into recall, this is my formula when I had a binary classification problem. Now when I have to compute basically for mean F1 score, there is going to be a small difference. Difference is, instead of calling it as precision, I am gonna give a little different name to it. So if I have to calculate for F1 micro, I would use the same thing 2, but this time I'm gonna say precision of which is precision which is coming from micro. I will explain you what is the formula for precision of micro, but before that I just want to tell you that how this F1 micro gonna be little different. Then after that recall micro, so this is also being calculated in a different way. Precision micro plus recall micro. Okay, this is going to be the formula for F1 micro. But now the question is how to get this precision micro and recall micro in this case. To understand this part, again we're gonna use almost the same thing. So like I'm gonna say precision micro, which is what I have to compute here. Now I will use the same thing. I will use the TP, which is basically gonna be happening here. I'm gonna put TP here also plus FP. Now I'm just gonna tell you what's gonna be the difference gonna come here. I'm just gonna sum this up for all K belonging to C. Now what is basically my C here? C is nothing but my set of all the tag, set of all the tags. Okay, now means it could have been like t1, uh, t2 till tn, right? Because these are like set of all the tags possible in this case. So this is going to be my true positive. So what I'm basically going to do is just going to put this summation for all. Now here also for this summation, I'm going to sum it up for all k belonging to C. Okay, this is what this sum will be for all the component. So this is what going to be the difference here. Similar thing I'm going to do for recall also. So let's say for recall micro, I'm just going to say here basically the same thing from k belonging to C, true positive. Let me in fact make it little more precise, because I'm putting k belong to C, right? So I should definitely put a k, because k would be any of this value. I will talk about that. So this tpk, and then again k belonging to C, and this is going to be your value tpk plus fnk, right? This is going to be a value in this case. So this is how you will be defining this value. So what I'm basically doing, if you look at this, my basically k is what? My k is belonging to C, right? My k is belonging to C here. And C is nothing but set of all label. So now k could be any of these tags, right? T1, T2, T3 till Tn. K could be any of these tags. So let's say if I pull up any of the tag T2 here, okay, so what I'm doing is for this T2 tag, I will compute basically a true positive. Similarly for T1 tag, I will compute a true positive, and I will also compute the false positive and false negative. So for every tag, I will compute the false positive, true positive and false negative, and keep on plugging in this formula, and I will keep on doing this for all the tags which are basically present here. That is what I'm doing. So for each k, I am basically doing nothing but calculating my true positive k, false positive k, and I'm calculating false negative k. And then I'm summing it up according to this particular formula, right? So this is what I am going to do in this particular example. Now, while doing this, there is a very interesting property which also comes up. So let's say I have a T1 tag, which is, let's say, occurring 90% of the time. Similarly, I have a T2 tag, which is, let's say, occurring only 1% of the time. Similarly, I have a T3 tag, which is, let's say, occurring 80% of the time. So you can notice that this is going to be very few, right? So in this case, my true positive for T2 tab is going to be low, right? It's going to be low. So that means what? If I will go in this formula, so the contribution from T2 tag in this is going to be low. So in the micro setting, we are also considering if the class is kind of imbalanced. If there are some tags which are occurring very high and some tags which are occurring very low. So this is also kind of considering that into the formula. On the other hand, this is not going to happen when you will go with macro basically system, and that's the reason micro is most preferred, and even in this competition we are being asked to use micro and not macro. So in this case we will be kind of looking at all these values, and we will be kind of working on all these tabs part. So you can notice that definitely it micro is taking care of a lot of stuff for us. Now let me explain you what we do for macro. Okay, so I hope now you are very clear how the micro system works. It's going to look at all the tags and calculate the true positive for each tab, false negative for each tab, and so on. Right, so we will basically put across the values. On the other hand, what we do basically for macro, I'm talking about macro now. So for macro setting, what we do, let's say I have a tag 1, tag 2 till tag tn. So what we will do, we will compute an F1 score for it. We will compute an F1 score for it. We will compute an F1 score for it. And then what we will do, when I have to compute F1, basically which is going to be your macro, I'm really sorry, macro. So when I have to compute this, I will do an average. Basically, this is the length of all the tags. So I have T1, T2 till Tn. So there are n values out of it. So then in that case, this C will become n, right? Now, then after that, I will sum up all these values basically for F1 score. F1 score, because I'm just calculating F1 score for 1, F1 score for 2, this is F1 score for n, like this, right? So this is the same thing. In fact, I should have put K here, right? That would have made more sense. So here in macro setting, if you look closely, we are not considering the points which basically are low side occurring, because this is just taking the F1 score. So due to this, we are not basically considering if any tag is occurring more or less, because we are basically giving the F1 score. So F1 score can still be high if you have low precision and low recall, right? Because there will be other tags which can basically cover that. But here, in this case, that's the reason macro is not preferred, and we are going to go in this competition with micro. Coming back to this, so now with all this explanations what we have done here, so in this case we are going to use the same micro this part, and I've explained you now in detail what to do for it. If you want to go and read more about it, please do follow these links which I have given you. Even scikit-learn do support the basically this micro score. You can even follow this link there. There is also one more interesting loss. This is called as Hamming loss. This is not that popular, but still this is worthy enough for me to talk about it. So I will be talking about this in the next lecture.